Welcome to the deep dive. Generative AI is absolutely everywhere these days, isn't it?
It really is.
From crafting essays, helping us code, its potential seems, well, limitless.
Mm-hmm.
But here's the burning question we often overlook.
Yeah.
How much tangible, quantifiable impact is it actually having in the real world?
Mm.
It's easy to get lost in the buzz, the future promises. But today, we're cutting through all of that. We're going to take a deep dive into a groundbreaking study from Meta that puts real numbers on AI's economic impact.
Yeah, specifically in the massive and, let's face it, highly competitive world of online advertising.
Exactly.
That's right. Our mission in this deep dive is precisely that. To move beyond the theoretical, the hype cycles, and really reveal the technical ingenuity behind how large language models, LLMs, are being meticulously fine-tuned for measurable, concrete results.
Okay.
We'll be exploring a cutting-edge technique called reinforcement learning with performance feedback, or RLPF,
LPF, got it.
and seeing how it powers a system they call AdLlama to generate demonstrably more effective ad text on platforms like Facebook. This is all about understanding the technical choices made, the engineering challenges they overcame, and their direct, proven implications.
Right. In a very significant industry, it touches billions of dollars, countless businesses.
Absolutely.
And the fascinating paper guiding us today is titled Improving Generative Ad Text on Facebook Using Reinforcement Learning, published by researchers at Meta Platforms.
It's a really good one.
Yeah, it's a fantastic in-depth look at a real-world application of advanced AI. It gives us this rare glimpse into how these technologies translate into quantifiable business value.
Mm.
We've all heard the buzz about generative AI and its transformative economic potential, right? It's constantly pitched as poised to revolutionize industries.
Everything from content creation, education, medicine.
Complex decision-making, yeah.
Yeah.
But what does that really mean for you, whether you're, say, a business owner, a marketer, maybe a developer, or just someone curious about where this tech is headed?
Right. Where is it actually showing up with measurable benefits today?
Exactly. The paper we're diving into points to pioneering work that has already demonstrated quantifiable benefits in areas like customer support, those tricky enterprise information tasks,
Legal work, software development.
email marketing, a whole variety of professional writing. It's
Yeah.
not just a future promise, it's genuinely happening now, creating tangible value.
To truly grasp this, though, we need to clarify the fundamental stages of LLM development because it's really a journey, not just a single step.
Okay.
The initial foundational phase is what we call pre-training.
Retraining.
Yeah, imagine it like raising a child that will eventually become this brilliant linguist and encyclopedia all rolled into one.
Okay.
During pre-training, an LLM learns general language patterns, syntax, grammar, and just a vast amount of world knowledge. It does this by simply reading through immense unlabeled text data, trillions of words from the internet, books, articles, basically everything you can imagine. This phase is all about building a highly capable, broadly intelligent foundation model, giving it a general understanding of how language works, what information exists, the relationships between words and concepts. It's like teaching it to speak and comprehend, but crucially, without a specific job in mind yet.
Okay, let's unpack this a bit more. So pre-training builds this incredibly powerful brain, right, this generalist.
that?
But then comes the post-training phase. And you're saying this is where the magic truly happens in aligning the model for specific real-world applications.
That's it.
This fine-tuning step, often overlooked in the public discussion, you're saying, is absolutely critical for achieving real-world impact. Why is this tailoring step so profoundly important? Why can't we just use that big pre-trained brain as is?
That's a great question, and it highlights a crucial point. A pre-trained LLM is, like you said, a brilliant generalist. It knows a lot, but it doesn't necessarily know how to apply that knowledge effectively to a specific task. Right. Or how to speak in a particular tone, or how to optimize for a specific outcome. Post-training is essentially this suite of sophisticated methods designed to adapt these broad, pre-trained models for very specific downstream tasks.
Yeah.
And we can categorize the leading techniques that are currently in widespread use. Each has its own strengths, its own applications.
Right.
First, there's supervised fine-tuning, or SFT.
SFT.
This involves training models to mimic curated target responses. Think of it like a student learning by meticulously following a specific set of ideal examples and detailed instructions provided by a teacher. They're aiming for a very precise output.
So like learning by example.
Exactly. If you want an LLM to generate code, you give it thousands of examples of code snippets that correctly solve specific problems.
Hmm.
If you want it to summarize articles, you provide pairs of articles and their perfect human-written summaries. The model learns by directly imitating these ideal outputs. This method is excellent for tasks where you have clear, high-quality examples of what you want the AI to produce.
Okay, that makes sense. What else?
Then you have reinforcement learning from human feedback, or RLHF.
RLHF. Okay, heard of that one.
Yeah, it's become quite famous. This technique trains the model not on what to say exactly, but on what kind of responses humans prefer.
Ah,
So
right.
here, humans are presented with multiple responses from the LLM for a given prompt, and they're asked to indicate which one they prefer, maybe ranking them best to worst.
So it's like a taste test for AI responses.
Kind of, yeah. And the model is then tuned to generate responses that align with those aggregated human preferences. It's proven highly effective for more subjective tasks, like generating creative prose or engaging in open-ended chatbot dialogue where defining quality can be inherently difficult to do objectively.
Right, like, is this chatbot helpful or friendly? That's subjective.
Exactly. It allows the model to learn nuanced preferences,
Yeah.
tone, helpfulness, safety things that are hard to codify into explicit rules.
Interesting. And you mentioned a third one.
Yes, and more recently, we've seen the emergence of reinforcement learning, or RL, with verifiable rewards.
Verifiable reward.
Okay. This is a significant step because researchers are now using objective signals that can be automatically validated without needing direct human judgment in loop for every single instance.
How does that work?
Well, imagine a model that's supposed to solve math problems. Instead of asking a human if the answer is good, you can automatically check if the answer is mathematically correct.
Ah, right. Binary, yes or no?
Precisely. Or if it's generating code, you can run tests to see if the code actually compiles and executes successfully. This approach has shown marked improvements in LLM reasoning and problem-solving capabilities, pushing models towards more definitively correct and performant outputs by providing clear, unambiguous feedback signals. It's about leveraging outcomes that can be programmatically verified.
So this is where the aha moment for this particular meta-study truly crystallizes, right?
Exactly.
Despite post-training's critical role and its effectiveness, its specific economic impact has been relatively underexplored and, crucially, largely unquantified, especially in these large-scale real-world settings.
Mhm.
We hear about AI saving time or improving processes, but rarely do we see direct, hard numbers on its business value. This is precisely where the meta-study makes its significant mark. It provides tangible numbers, real insights, demonstrating actual economic benefit.
That's absolutely right. And the study zeroes in on the online advertising industry for a very good reason. It is a truly massive driver of the global economy.
Huge.
And critically, its outcomes are incredibly measurable. To give you some context, worldwide expenditure in online ads is projected to reach an astounding $513 billion USD in 2025.
Wow, $513 billion.
And it's expected to represent 63% of the total global advertising revenue across all mediums.
So nearly two-thirds of all ad spend globally is online.
Yeah, think about that. This domain offers a perfect environment to quantify the impact of AI because its outcomes, things like clicks, conversions, engagement rates, are so directly and precisely measurable at scale.
Right, you can track a click very easily.
Exactly. This inherent measurability is key to proving the economic value of AI and moving it beyond just abstract concepts. It allows for a direct link between an AI's output and a business's bottom line.
So, given this context, how did Meta actually apply generative AI to this huge, economically significant area?
Well, they have a powerful feature within Meta Ads Manager, that's the platform millions of businesses use to run their campaigns,
Right.
called text generation. This tool is designed to help advertisers create new variations of their existing human-written ad text.
Okay, variations.
Yeah, the core idea is to allow advertisers to select multiple versions of an ad, empowering Meta's sophisticated ad delivery systems to then automatically show the most performant variants to potential customers. It optimizes for engagement and efficiency.
So it's giving advertisers more shots on goal, essentially.
Precisely. More ammunition in their campaigns. The user interface for this is quite intuitive, as they show in the study. An advertiser provides their original ad text, maybe something like, "Spend your weekend with a new book. Visit us today."
Hmm.
The underlying LLM then generates and displays several new text variations based on that input.
Like rewrites or different angles.
Exactly. And from there, advertisers have a lot of control. They can pick the ones they like. They can edit them directly in the text box if they want to tweak a word or phrase.
Oh, cool. So you can fine-tune the AI's suggestion.
Yep. Or they can even add their own completely custom variations using an add text option button if they've thought of something the AI didn't.
Nice.
There's also an option to generate more for additional ideas, cycling through possibilities. But there's a limit. Advertisers can select a maximum of 5 variations for actual delivery to users.
Why the limit?
It likely ensures the system remains manageable and effective for A/B testing. Too many variations might dilute the results or make it hard to determine which one truly works best.
Gotcha. It's really important to note the nuanced role of the AI here, because it's not simply replacing human creativity, is it?
Not at all. Advertisers are never required to use the AI-generated ads. They retain full control, which is absolutely crucial for trust and adoption.
Right.
They can choose to ignore the AI suggestions completely, stick with their original text, or maybe provide multiple human-written variations instead.
Or edit the AI suggestion.
Exactly. Edit the AI-written text before selecting it, tailoring it to their exact brand voice or specific promotion. Or they might simply use the AI-generated suggestions as inspiration, sparking new ideas they hadn't considered for their own human-written copy.
So the LLM acts as a powerful assistant, a creative partner almost.
That's a good way to put it. It shapes and influences ad text, even if its exact wording isn't always adopted precisely. It amplifies human capability rather than replacing it.
Okay, so what was powering this initially, before this new AdLlama model?
The initial version of this text generation product, which first launched back in November 2023, used an LLM that was, in the paper's words, trained in a naive manner.
Naive? How so?
This model, they called it Imitation LLM v1, was based on Meta's open source 7 billion parameter version of Llama 2 Chat, a foundational LLM from Meta.
Llama 2.
But crucially, it was post-trained using supervised fine-tuning, SFT, specifically to imitate the style and characteristics of a set of pre-curated ads. It was taught to sound like good ad copy by seeing many examples of good ad copy.
So how did they curate those ads that Imitation LLM v1 was supposed to learn from? What was in its textbook?
Good question. For V1, the initial training data set was entirely based on synthetic generations.
Synthetic, meaning AI generated.
Exactly. They used a larger, even more capable 70 billion parameter Llama 2 chat model to generate ad text examples, rather than using real human-written ones. Imagine asking that huge model, give me 10 variations of this ad that are shorter and more direct.
Okay, and then they improved on that.
Yes. For an improved version, which they called Imitation LLM v2, they diversified the training data. They still use synthetic data, but they also included human-written examples, specifically ad texts created by professional contractors, expert copywriters.
Bringing the humans back in.
Right. These training examples, whether synthetic or human-written, were meticulously created by prompting either the larger LLM or the human contractors to rewrite existing ads using very specific instructions.
What kind of instructions?
Things tailored to common ad copywriting goals that advertisers often have, like paraphrase and shorten, make clear and concise, make actionable, empathize with the customer, pose as a question, or focus on a specific selling point.
Got it. So very targeted rewrites.
Exactly. Now, while the synthetic data offered maybe more creativity and diversity, it sometimes came with higher hallucination rates.
Meaning it made stuff up.
Yeah, or produced text that wasn't quite accurate or relevant. The human-written data, on the other hand, was consistently higher quality, more reliable, but maybe offered less diversity in style. Imitation LLM v2 aimed to strike a balance, leveraging the strengths of both.
Okay, so Imitation LLM v1 and v2 were basically trained to mimic good ads.
Correct.
So the fundamental goal of this new work, the AdLlama stuff we're diving into today, was to go beyond just imitation.
Precisely.
It was about moving from simply sounding like good ad copy to demonstrably performing like good ad copy. Specifically, they wanted to quantifiably improve advertiser performance, measured directly by click-through rate, using this novel reinforcement learning approach.
That's the core idea. This is where AdLlama truly enters the picture, marking a significant leap forward.
So let's get into that. Reinforcement learning with performance feedback, RLPF.
Right. As we've discussed, traditional LLM alignment methods like the widely used RLHF often rely on subjective human preferences.
The "I like this one better" approach.
Exactly. Which is incredibly valuable for many tasks, making a chatbot friendly, helpful. But these preferences can be noisy, inconsistent, and most critically for advertising, they might not perfectly align with an advertiser's ultimate concrete business goals.
Which are usually about driving measurable action, return on investment.
Absolutely. Humans might prefer a certain ad text aesthetically, but that doesn't guarantee it leads to more clicks or sales.
Here's where it gets really interesting then, and where Meta had this pivotal insight. Unlike creative writing or open-ended chat, where good is subjective, the task of crafting effective ad text has a very clear, quantifiable, objectively measurable objective. The click-through rate, CTR.
That's the key. CTR is simply the ratio of clicks to total ad impressions, how many people who see the ad actually click on it. It's a direct measure of engagement.
Right. And you mentioned conversion rate is the ultimate goal, but CTR is less noisy.
Exactly. Conversion data, like a purchase, can be sparse, delayed, harder to attribute directly sometimes. CTR is much more immediate and frequent, making it a more practical metric for this type of iterative training.
And this principle holds true beyond ads, right? Anywhere there's a concrete performance metric.
Definitely. E-commerce product descriptions aiming for add-to-cart actions, AI customer support optimizing for resolution rates. If you can measure a performance outcome, you can potentially optimize for it using a similar approach.
Okay, so this insight led directly to RLPF.
Yes, reinforcement learning with performance feedback. It's fundamentally a metric-driven extension of RLHF. It moves from human preference to direct performance.
How does it work? You said 2 steps.
Right, a clear two-step general approach. First, they train a performance reward model using aggregate performance metrics, specifically historical CTR data in this case.
So a model that predicts performance.
Exactly. This model is designed to assign a numerical score, a reward, to a given piece of text, where higher scores consistently indicate more performant text, meaning ad copy that generates more clicks based on past data. Think of this reward model as a highly skilled, objective ad critic.
Trained only on what actually works.
Precisely, not just what sounds good. Then second, once this reward model is trained, it acts as an interactive environment for reinforcement learning fine-tuning.
Okay, using the reward model to train the main LLM.
Correct. The explicit goal here is to adapt the large language model, the LLM, to become more likely to generate text that earns a high reward from this performance model. It closes the loop by directly optimizing the LLM for the desired real-world outcome, making it generate ads that the critic predicts will get more clicks.
Okay, that's clever. But if you're building a reward model based on actual ad performance, where do you get that critical data? You need historical records of what worked and what didn't.
Great question. Meta had a pre-existing advertiser tool that proved invaluable here. It was called multiple text optimization.
Multiple text optimization.
Yeah, this feature allowed advertisers to manually submit and test various versions of their ad body text to see which performed best. It was essentially a built-in A/B testing system for ad copy, and crucially, it collected exactly the kind of data they needed.
So they already had a treasure trove of performance data.
Pretty much. This multiple text optimization feature provided invaluable multi-text data. This data consisted of historical ads where all components, the image, the video, the ad title, the targeting criteria remained constant.
Okay, everything else the same.
But the ad body text itself varied. This controlled variability is absolutely crucial.
Why crucial?
Because it allowed the researchers to isolate and attribute any observed differences in click-through rate, the CTR, directly to the ad body text variations themselves. Without that control, it would be much harder to definitively say, was it the image that drove clicks or the text? This data allowed them to pinpoint the impact of the text.
Right, isolating the variable. Makes sense. And from this multi-text data, they constructed preference pairs. Walk us through that.
Certainly. Imagine two ad texts, text A and text B, that were shown side by side to similar audiences as part of one of these multiple text optimization experiments.
Oh.
If text A generated a measurably higher CTR than text B, then text A was marked as more preferred and text B as less preferred in a pair. They show this nicely in Figure 3 of their paper.
So comparing two texts directly based on performance.
Exactly. This pairwise dataset supports the standard Bradley-Terry preference-based approach, which is a well-established statistical method for training models to rank items based on these pairwise comparisons.
Okay.
They did consider a simpler point-wise dataset, just the ad text and its associated CTR score, but they found the pairwise approach was significantly better at discerning the crucial ranking between similar ad
Why
texts.
is ranking better than just knowing the score?
Because often you're comparing two pretty good ads. It's not just about knowing if an ad is good, its score, but how much better it is compared to another good ad. That relative difference is what truly matters for fine-grained optimization.
Got it. So they built this pairwise data set. How did they train the reward model itself?
They used a negative log likelihood loss function. It's a common technique in machine learning.
Sounds complex.
Conceptually, think of it this way. The model tries to guess, for every preference pair, which ad text will perform better. This loss function is like its internal scoring system. It penalizes the model heavily when it gets the order wrong, or if it assigns a low score to a high-performing ad.
And rewards it when it gets it right.
Exactly. The objective was to minimize this loss, which in turn maximizes the probability that the preferred ad text would receive a higher predicted reward score from the model compared to the less preferred text.
And how well did it work?
Through this rigorous training, they achieved approximately 57% out-of-sample pairwise accuracy for their reward model.
Now, 57%, that might sound low to some people, right? Like just slightly better than a coin flip.
That's an excellent point, and it's important context. 57% might seem modest if you're thinking about, say, distinguishing cats from dogs, where you might expect 99% accuracy.
Right.
But remember, this model is discerning between often subtle differences in ad copy that are already pretty good, operating in a highly competitive, highly optimized environment. It's not trying to pick a good ad from a terrible one. It's trying to pick the slightly better ad from two already competent options.
Okay, so the baseline is already high.
Exactly. Even a slight but consistent edge in predicting which ad will perform better, that 57% means it's right more often than wrong, when applied across millions of ads and billions of impressions, translates to massive cumulative gains.
Ah, okay, scale matters.
Immensely. It's like having a slight but consistent advantage in a highly competitive race. Over time, that small edge makes all the difference. It shows the model has learned genuine predictive power about ad engagement, even if the absolute number seems small initially.
Okay, that makes sense. So you have this performance reward model, this critic, that's better than chance at picking the winning ad text. How do you actually use it to make the LLM, the generator, create better ads?
Great question. How do you train the artist using the critic? The Meta team employed a well-known reinforcement learning algorithm called proximal policy optimization, or PPO.
PPO. Okay.
PPO is designed to find an optimal policy in this case, the LLM's way of generating text by iteratively adjusting it based on the rewards it receives from the environment. And here, the environment is our performance reward model.
So the LLM tries generating text, the reward model scores it, and PPO uses that score to tweak the LLM.
That's a core loop, yes. But what's absolutely key here is how they specifically adapted PPO for this advertising context to make it practical and effective. They didn't just use vanilla PPO.
How did they adapt it?
A crucial addition was a length penalty in the optimization objective.
Length penalty, why?
It was a vital technical detail to counteract a common tendency for generative models when optimizing purely for reward to produce ad text that is simply too long for an effective ad.
Ah, right. People scroll past long ads, especially on mobile.
Exactly. So the full optimization formulation is multifaceted. It involves maximizing the expected reward from the generated text, get higher scores from the performance critic. But it also penalizes deviations from the original LLM's distribution.
What does that mean? Penalizing deviations.
They use something called Kullback-Leibler divergence, or KL divergence. Think of it as a leash.
A leash.
Yeah. While PPO wants to push the model to generate super high-performing ads according to the reward model, the KL divergence term ensures it doesn't stray too far from its original training, its original personality, or language style.
So it still sounds like coherent natural language.
Exactly. It prevents the model from generating ads that might score well according to the critic, but sound completely alien, grammatically incorrect, or just nonsensical to a human user. It maintains language quality and fluency.
Okay, so maximize reward, stay fluent.
And, critically, the length penalty explicitly discourages rambling. This multi-objective approach ensures the model generates text that is both performant and practical, adhering to the real-world constraints of the ad format.
That's really clever engineering. So this AdLlama model, the one trained with RLPF using PPO, it originates from the very same 7 billion parameter Llama 2 chat-based model. as the earlier imitation LLM v2.
Correct. Same foundation.
But the fundamental difference, as they highlight really clearly in Figure 4 of the paper, is the training method.
Absolutely.
AdLlama is trained via RLPF using historical ad performance data real-world user clicks, whereas imitation LLM v2 was trained with SFT using curated examples, synthetic or human-written.
It's a fundamental shift from imitation to direct outcome optimization, from sounding good based on examples to actually doing good based on performance metrics.
It sounds powerful, but does it have potential pitfalls?
Yes, and this transition isn't without its challenges. A known issue when using PPO for fine-tuning LLMs is something called over-optimization, or more colloquially, reward hacking.
Reward hacking. Sounds
Yeah.
mischievous.
It kind of is. It's where the model starts optimizing for imperfections or biases within the reward model itself, rather than truly improving the underlying quality of the generated text that translates to real-world performance.
Can you give an example?
Imagine if your ad critic, the reward model, had a slight, maybe unintentional bias towards ads that used, say, lots of exclamation marks.
Okay.
The LLM, through PPO, might learn to just pump out ads with tons of exclamation marks because that gets it a higher score from the biased reward model, even if those ads aren't actually more engaging to real humans. It's gaming the system.
Finding loopholes in the reward model. How do they address that?
They demonstrated meticulous attention to detail here. They carefully selected the optimal model checkpoint during training. They didn't just take the model that got the highest reward score during training.
How did they pick the best one then?
They used a combination of strategies. They closely monitored the LLM training process using an evaluation reward model trained on a completely separate data split, a fresh set of data the main reward model hadn't seen, to check for generalization.
Like a second opinion from another critic.
Exactly. And they also incorporated a small-scale human preference labeling process as a final sanity check, getting humans to look at the outputs. This multi-pronged validation approach speaks to the rigorous and careful nature required when deploying these powerful models in a real-world, high-stakes setting.
Makes sense. You need those checks and balances. Okay, so they built AdLlama using RLPF, carefully avoiding reward hacking. How did they prove it actually worked better in the real world?
This is where it gets really compelling. The true proof of concept for AdLlama wasn't just confined to a lab or simulation. It was put to the ultimate test in a large-scale, real-world A/B test.
A randomized control trial, right, conducted directly on Facebook.
Exactly. This is where we truly see the rubber meet the road and ascertain the model's practical impact, not just its theoretical promise. You don't get much more real world than that.
How big was this test?
It ran for a substantial period, 10 weeks, from February 16th to April 25th, 2024. And it was massive, designed for statistical significance. It involved nearly 35,000 advertisers based in the United States.
35,000 advertisers, wow.
Yeah. These advertisers were randomly assigned to either a control group, who continued to receive the existing imitation LLM v2 in their text generation tool.
The baseline.
Right. Or a test group, which received access to the new AdLlama model trained with RLPF. This randomized setup, which they visualize nicely in Figure 5, is crucial.
Why? What does the randomization ensure?
It ensures a fair and unbiased comparison between the two AI approaches. By randomly assigning advertisers, you minimize the chance that any observed differences are due to pre-existing differences between the groups of advertisers, rather than the AI model itself. It means any difference observed can likely be attributed to the AI model being tested.
Okay, fair comparison. What were they measuring?
Their primary focus was on advertiser-level performance. That means performance aggregated over all direct response ads created by an individual advertiser during that 10-week experimental period.
Okay, direct response ads. Remind us what those are again.
Direct response ads are those specifically designed to optimize for engagement or immediate user action.
Like clicks, purchases, installs.
Exactly. Driving clicks to a website, purchases from an online store, app installs, signups for a newsletter. They are distinct from brand ads, which might just aim for brand awareness through views or impressions without necessarily prompting an immediate action.
And since AdLlama was designed to improve engagement.
Precisely. The click-through rate, CTR, on these direct response ads was the most relevant and critical metric for evaluation. It directly reflects how effectively the ad copy is prompting users to act.
Makes sense. What else did they track?
They rigorously track total engagement, clicks, total impressions, views, the total number of distinct ads created, and importantly, the total number of ad variations created using the tool.
To see if behavior changed too.
Exactly. They also log numerous advertiser characteristics. They call these covariates, things like the advertiser's CTR before the experiment started, their account age on the platform, their business vertical, like retail, finance, tech,
Why log those?
to ensure the groups were statistically balanced at the start of the experiment. And they confirmed they were, which further validates the fairness of the comparison.
Okay, the setup sounds incredibly rigorous. So what was the headline result? Did AdLlama make a difference?
It absolutely did. The central finding from this massive A/B test is undeniably compelling. AdLlama provided a statistically significant 6.7% increase in advertiser-level CTR compared to the naive imitation LLM v2.
6.7%. That sounds significant.
It is very significant in this context. The p-value for this result was 0.0296, indicating strong statistical confidence. It's highly unlikely this result occurred by random chance.
Wow. Okay, put that 6.7% in perspective for us.
Sure. While a 6.7% relative increase might sound modest on its own, it roughly corresponds to an absolute increase in advertiser-level CTR from, say, 3.1% to 3.3%.
Okay, 0.2 percentage points, absolute difference.
Right. Now, you might think that's only 0.2 percentage points, but this is a truly substantial improvement in an advertiser's return on investment on Facebook ads, on mature, hyper-optimized ad platforms like Facebook.
Where everything's already squeezed for efficiency.
Exactly. Where every fraction of a percentage point is fiercely optimized for through years of A/B testing and algorithmic improvements, even seemingly small increases in CTR are typically very, very difficult to achieve. A 1% gain in CTR on a platform the size of Meta can translate to hundreds of millions, if not billions, in additional revenue and advertiser value annually.
So in that context, 6.7% is a major, major win.
It really is. It's a clear validation of the RLPF approach. It's not just an increment. It feels like a significant leap.
And the statistical rigor here you mentioned was impressive. They didn't just rely on one number.
Not at all. They ran multiple robustness checks to validate their findings from every angle. They wanted to be sure this wasn't some statistical artifact.
Like what kind of check?
Well, they used model-free estimates. For instance, Figure 6 in the paper vividly shows the control group's global CTR at 0.0304 versus the treatment group's 0.0344. You can visually see the gap, and it was statistically significant.
Okay, seeing is believing sometimes.
Right. Beyond that, they also tested alternative regression specifications using different statistical models like logistic and Poisson regressions, which are often suited for this type of count or rate data. And all of these independently yielded qualitatively similar effects.
So different ways of slicing the data all pointed to the same conclusion.
Exactly. It powerfully reinforces the core finding that AdLlama boosts CTR. It wasn't just a fluke of one specific analysis technique.
Did they look deeper into why the CTR went up? Was it more clicks or fewer impressions or?
Great question. They did exactly that. They conducted separate linear regressions specifically on the number of clicks and the number of impressions.
And what did that show?
It was quite revealing and speaks directly to the quality of the AI-generated text. They found that AdLlama specifically increased the total number of clicks per advertiser.
Okay, more clicks.
While it did not significantly affect the total number of impressions delivered.
Ah. So the ads were shown about the same amount, but got clicked more often.
Precisely. This directly supports the finding that the CTR increased because AdLlama was generating more engaging, more compelling ad text. That improved text then led to more clicks for the same number of views or exposures.
So it wasn't just gaming the delivery system somehow. It was actually better ad copy.
That's what the data strongly suggests. It improved the quality of the ad copy, leading to better user engagement.
That's fascinating. Now, beyond just the cold, hard performance metrics, how did AdLlama influence how advertisers actually interacted with the tool? Did they use the AI suggestions more? Because a tool can be powerful, but if users don't adopt it.
That's a critical point for real-world deployment, absolutely. And the results here were also very interesting. They found strong evidence that using AdLlama increased the number of ad variations created by advertisers.
More variations created, okay.
What's particularly interesting is that while the number of variations went up, the total number of distinct ads created remained statistically the same.
So advertisers weren't simply creating more campaigns overall.
Correct. They were creating more options for each ad campaign they did create. Specifically, the number of ad variations increased by 3.1 on average per advertiser over the 10 weeks.
3.1 more variations. What was the baseline?
It jumped from roughly 16.8 variations with the imitation LLM v2 to about 19.9 variations with AdLlama.
Okay, so roughly 17 to 20 variations. That's a noticeable jump.
It represents a significant 18.5% increase in the number of variations advertisers were willing to generate, select, or experiment with.
Wow, 18.5%. What does that suggest to you?
It strongly suggests that for each ad, advertisers were more willing to adopt and experiment with the text generation product's suggestions when those suggestions came from AdLlama.
They found them more useful, perhaps, more relevant.
That's the likely interpretation. It's a clear indicator of higher advertiser satisfaction and adoption of the AI's outputs, which has its own profound downstream implications for the platform's utility and the overall advertiser experience.
Yeah, it shows the AI is truly helpful in their workflow, providing value beyond just the raw performance numbers. It's about trust and utility.
Exactly. It's one thing to have a model that performs well in theory. It's another to have one that users actively engage with and find valuable.
Okay, so summing up the core findings. AdLlama, trained with RLPF using real performance data, significantly boosted advertiser CTR by 6.7% compared to the imitation model.
Check.
And advertisers actually created and used significantly more ad variations generated by AdLlama, suggesting higher utility and satisfaction.
That's the story the data tells. This work unequivocally demonstrates that reinforcement learning with performance feedback, RLPF, can effectively train LLMs to generate ad text that not only resonates with advertisers, but, more importantly, drives measurable engagement from users on a massive scale like Facebook.
It feels like a crucial validation of the whole RLPF methodology.
It absolutely is. It proves its real-world applicability and effectiveness in a highly competitive domain.
And it strongly supports that core concept of anchoring the fine-tuning process in real-world aggregate performance metrics, doesn't it?
Yes, it marks a significant shift from relying solely on subjective human preference feedback, or maybe arbitrary rule-based rewards. It's about directly optimizing for outcomes that matter to a business.
Letting the data drive the optimization.
Precisely. Letting the data speak for itself about what actually works.
Now, while this is groundbreaking, the authors were pretty transparent about limitations in future work, weren't they?
Yes, very much so. Good scientific practice. They acknowledge several areas for future technical development.
What were some of those?
Well, for instance, the current model was trained using offline historical performance data. That's essentially a single round of offline reinforcement learning based on past results.
Oh.
To further refine the model, future work could incorporate the performance outcomes of LLM-generated ads in an iterative process, moving towards what's known as online RL.
Online RL. How would that work?
It would allow the model to continuously interact with the live environment. It generates ads, sees how they actually perform in real time, gets that feedback, and adapts. It could potentially discover new trends in ad effectiveness through ongoing exploration and learning.
So constantly self-improving based on live results.
That's the idea. Imagine the model learning daily from how its newest ads perform.
That sounds powerful. What else?
Another limitation is that the current model primarily focuses on optimizing for ad performance, specifically CTR.
Right, the main goal.
But other factors are also critically important for advertisers and the platform. For example, there can often be a trade-off between generating ads that perform extremely well in terms of clicks.
And ads that are maybe more creative or stick to a specific brand voice.
Exactly. An ad might be super clickable, but maybe slightly off-brand or not very innovative. Or it might perfectly match the advertiser's specific instructions on tone, which is vital for brand integrity, even if it slightly lowers CTR.
So balancing multiple goals.
Right. Addressing these nuances would require a more sophisticated multi-objective optimization approach, trying to balance various objectives effectively within the LLM's output, effectiveness, creativity, brand alignment, adherence to instructions, making sure it's not just effective, but also meets these other critical criteria.
That sounds like a complex challenge.
It definitely is. Another interesting point they raised, the current model doesn't explicitly account for the human component of the text generation product.
Meaning the fact that an advertiser has to choose the AI's suggestion.
Precisely. The LLM might generate a fantastic ad according to the reward model, but if the human advertiser never picks it, maybe because it looks weird or they just don't like it, it never gets shown. Its potential performance is irrelevant.
So, bridging the gap between predicted performance and human acceptance.
Exactly. Future iterations of the RLPF reward model could try to incorporate this, maybe by weighing the predicted CTR by the likelihood that the text is actually selected by advertisers, integrating that human gatekeeping decision directly into the reward signal.
So training the model to generate ads that are both high-performing and likely to be approved by a human.
That would be the goal, get the best of both worlds.
Any other future directions mentioned?
One more key area is platform-level factors. Beyond individual ad performance, things like maintaining the diversity of the ad inventory shown to users are important.
Why is diversity important?
For a positive overall user experience and preventing ad fatigue, if users see the same style ad over and over, even if it's technically high-performing, they might tune out. So future work should explore strategies that simultaneously consider these other factors while still optimizing for core performance metrics, creating a more holistic optimization for the entire ecosystem.
Fascinating. It really highlights how complex deploying these systems effectively is. But the implications of this work, this RLPF methodology, they seem to extend far beyond just online advertising, don't they?
Oh, absolutely. What's truly fascinating here is how generalizable this core approach could be.
How so?
This methodology, RLPF, is highly generalizable because its core principle is about optimizing for measurable outcomes. The underlying principles can be adapted to any domain where aggregate performance metrics are available and can serve as a direct feedback signal.
So anywhere you can measure success numerically.
Basically, yes. By using real-world performance data as a direct feedback mechanism, organizations can fine-tune LLMs to optimize directly for their desired business outcomes, whatever those may be.
Like what? Give us some examples.
Well, think about personalized email campaigns. The reward could be email open rates, click-through rates on links within the email, or even conversion rates from the email to a sale.
Okay, optimizing email copy for clicks or sales.
Exactly. Or consider e-commerce product descriptions. The reward might be sales conversions generated after viewing the description, or maybe time spent on the product page, or the number of items added to a part from that page. You could train an LLM to write descriptions that demonstrably lead to more sales.
The possibilities seem vast if you have that measurable goal.
There really are.
You could even extend it to settings with multiple rounds of interactive feedback, right?
Yeah.
Like AI customer support agents.
Definitely. In those scenarios, metrics like resolution rates for customer issues, customer satisfaction scores from post-interaction surveys, maybe even user response times could serve as direct reward signals.
So you could have an AI learning in real time how to resolve issues faster, more accurately, and leave customers happier, all based on measurable outcomes.
That's the potential. Constantly improving its interactions based on what actually works for the customer and the business.
And beyond the obvious business applications.
There are equally impactful, though perhaps less intuitive, scenarios. Think about online learning platforms.
Education, how would that work?
Student performance data, things like test scores, quiz accuracy, completion rates, even engagement metrics like time spent on learning modules could directly guide an LLM.
To do what?
To generate adaptive learning content that is more effective for individual students. Content tailored to their specific learning style, their pace, their areas of weakness, all optimized based on how well they actually learn from it.
Personalized education driven by performance data. That's powerful.
It could be. Or consider public awareness campaigns, things like promoting vaccination initiatives, healthy eating habits, energy conservation.
How would you measure performance there?
It's trickier, but you could use performance data like changes in public behavior tracked through surveys, or community engagement metrics, or signups for related programs. This data could enable LLMs to iteratively rewrite communication materials to better resonate with their intended audience, maximizing the impact and achieving critical public health or social goals.
So using RLPF to make public service announcements more effective.
Potentially, yes. This RLPF approach is a truly promising and, I think, generalizable way to bridge the gap between these highly capable language models and tangible, measurable outcomes across a vast array of industries.
It really connects the AI capability to real-world results.
Exactly. And for those interested in staying up to date on the latest AI and ML research papers, maybe diving deeper into technical advancements like RLPF, a great resource is neuralintel.org.
Neuralintel.org. Good tip. You'll find a wealth of information and cutting-edge research there.
Definitely worth checking out if this stuff fascinates you.
What a deep dive this has been. Seriously fascinating. We've unpacked the transformative potential of LLMs, the critical role of post-training, and this really ingenious reinforcement learning with performance feedback method that powered AdLlama.
Hmm.
We saw its proven, quantifiable impact on ad performance and even advertiser behavior through that massive real-world A/B test on Facebook. It really moved beyond the theoretical to the truly measurable.
It really did. This study provides such a concrete data point for the true, quantifiable impact of advanced AI fine-tuning. It shows the immense power of directly optimizing LLMs based on real-world business metrics rather than relying solely on subjective human preferences.
It's like a blueprint, isn't it? For leveraging AI not just for novelty, but for actual bottom-line results.
I think so. It sets a strong precedent.
So here's a final thought to leave you with. Consider this. How could this ability to precisely quantify and optimize LLM outputs based on direct business or performance metrics reshape not just advertising, but potentially redefine the value of AI across countless other industries?
Yeah, where else could this apply?
What other aspects of digital engagement, information generation, maybe even scientific discovery could truly benefit from this metric-driven approach? How could it transform how we interact with technology and achieve our goals? Something to think about.
Definitely food for thought.
You've been listening to The Deep Dive.
Uh,
Until next time, keep exploring.